Start recording. I need the rest of this stuff to go away. All right, anybody who's a gamer in here who streams, which buttons, what do I make to make this go away? I don't want to use this widget, I just want the window to go away.
I don't think we can see what you're seeing.
Oh, you can't? Oh, well, which was okay, except that I couldn't see my, it was this big on my screen, that big on my screen, from a screen perspective. All right, so we're recording now, and it should be all working out. I can actually see the record button, you can't, that's fine. So let's go ahead then and start with lecture. We have lots of stuff to cover today. Well, one more thing up here, math module. So we had a homework, the math module, I saw some of you had already done it. Number one is due on Wednesday at 7 a.m. 7 a.m. is going to be our magic number before class. We will certainly cover that material today. Okay, so yes.
If you did the math module and you didn't get like a good grade, that grade's still in the grade book, even if you
Wanted to redo it now?
Or like you took it and if you got a better grade.
So are you talking about the pre? So there's a pre-quiz.
Yeah.
You took the pre-quiz. You decided to do stuff, and then you took the post-quiz both.
Yeah.
Okay. So if you want to retake it, email me,
Okay.
and I'll try to figure out how to reset that.
Okay.
Okay. Or give you a different option. So if that's the case, if you're one of the people that took it early and you want to retake it, email me. I'll figure out how to fix that. There'll be some way.
It was only this one, right? No, the fractions one.
There's just math module 1, which I think is probably only sig figs, yes? Okay. Well, we may not use any of the other math modules. We'll see. Okay, so don't go on and do any more of them. If you've done one, great, but I didn't see anybody had done 2, but maybe I missed it. Other questions? All right, so we're talking about significant figures. And I want to remind you that significant figures are a way of communicating how accurate or how precise a measurement is. We'll say precise. So in other words, as a scientist, you are trying to communicate, this is how many of these numbers I trust, okay? So when we talk about the Stonehenge example, okay, the tour guide said it was 5,005 years old. He was communicating that he trusted it to the year, okay? He was probably incorrect. It was probably should have been correct, trusting it to the thousands of years or maybe hundreds of years. Okay, does that make sense? So his was an example of using them incorrectly, but he did communicate 4 significant figures, 5005. Okay, so let's talk about when digits, just talking about digits, are significant. Okay, they're significant when it's not a 0. Non-zero digits are significant. And then we're going to have a bunch of other rules for zeros here, okay? When zeros are between 2 numbers, so non-zero, non-digits, non-zero digits are significant. When a 0 is between non-zero numbers. Or digits, okay? So example here would be 5,005 years. Both those zeros are significant. So this is 4 sig figs. Okay? When a 0 is to the right of a decimal point and to the right of non-zero digits. Okay, so if I have 0.000, let's make it the size of a bacterium. 1, 2, 3, 4, 5, 6. Let's say I've got a really good microscope, and I actually can say I've got, that's my number, right? Meters. I'll start putting units on, because units are really important in chemistry. You're gonna always want to include your units when you have them. I will take off credit if you don't include units. Okay, and unlike significant figures where I'm going to enforce the rules strictly for a little while and then let up a bit, I will always enforce units. Okay, when I go to biochemistry, I'm super easy with significant figures. Okay, because I don't want people thinking about it too much. But I always care about units. And you'll find that's the same with other faculty as well. So, hold on. Let's make it that. Okay, to make it match this rule. So this 0 here is significant. I didn't need to write it, did I? These zeros are holding the place, and that 0 I didn't need to write. So that is significant. So that's 2 significant digits. Questions on that one? Okay. All right, when a 0 is underlined. So if I was to write 1200 years, it might be that I actually trusted this 0 here, right? So I plus or minus 10 years is kind of where I was, and that's going to be 3 sig figs. Questions? Okay, then let's move on and talk about how we do math with these. Well, let's talk about one other concept here first. We have exact numbers. These effectively have infinite significant figures. Okay? So, in other words, you don't use them when you're doing calculations. You don't limit the result based on how many significant figures these might have. And so, exact numbers are counting numbers. Okay? You know them exactly. On the quiz I just handed back, you have 1 picture of a cat. Okay? We know that. It's not 1.1 maybe or 0.9 pictures of a cat. All right? I handed back 30 quizzes today. All right? It's 30 exactly. I know it was 30. All right, so that's one example of an exact number. Another example of a number is definitions. So let's do counting numbers. 12 eggs would be an example of counting numbers. You know they're exactly 12 eggs if you count them. Definitions. 1 kilogram equals 1,000 grams. That's a definition. Okay? This is exact. This is exact if I use that in a calculation. Does that make sense? Okay. All right, now let's go on questions. All right, let's go on and talk about then how we would do calculations with significant figures. All right, and so we talked about, I'm going to review it since it was last week, adding and subtracting significant figures. All right, so the rule here is when you add and subtract significant figures, what you do is you keep, or your answer should have the same number of places to the right of the decimal point as everything else. Okay? I'm trying to figure out how to say that because it's also to the left of the decimal point. Okay? So it should have the same number of places to the right. So your answer should have the same number of places as the smallest, what do we call those places in math? You guys, was there a name for that? What was that?
Starting number?
Yeah, not starting number, I don't think, but thank you. As the smallest, we're thinking about tens place, hundreds place, tenths place, that decimal place. Let's call that as the smallest decimal place, or the least number, or the least number of decimal places. And by the way, I encourage you to take notes if that works for you. I want to remind you that I do post, not only will there be YouTube videos, but I do post these notes I'm writing right now on the website as well. If it's ever not up to date, please, I love reminders. It is currently up to date. Okay, so let's do an example of that. So, or a couple examples. So if we have 1,234 inches, okay, and we have 1,200 inches, right? How many sig figs for the top one? 4 sig figs. How many sig figs for the bottom one? 2 sig figs. Pretty easy for that. If we add these two together, what do we get? Well, we're going to get a 4 and a 3 and a 4 and a 2 inches. I'm not going to forget my my units, okay? But how many sig figs should my answer have? This goes out to the ones place, right? This goes out to the hundreds place. So my answer should be rounded to the hundreds place. All right, so my answer here would become 2,400 inches. Let's go make that a plus there. Questions on what I just did? Okay, the same thing works to the right of the decimal point. So I'm going to switch to just using my pen here. Let's say we're talking about 0.00021, okay? Let's go milliliters. All right, we'll switch to a volume here. And we're going to subtract from that 0.00000. Let's say that's a measurement, maybe some sort of human cell. I'm sure there are some human cells that match that. And then we're going to subtract from that the size of a bacterium. 1, 2, 3, 4, 5. Actually, let's make it an organelle. Milliliters. So we're going to subtract those two numbers. I'm going to make sure my digits line up here. Okay. So I can subtract those two numbers, right? I'd have to add a 0 here. I'm going to have to make that 10. Make that 0. I get a 5. I'm going to make that 1. Make that 10. I get a 9. 1, 0, 0, 0, 0, 1. Whoop, not 1. 0. Like that. Milliliters. If I look at that, where was this one is significant to that spot, right? Don't fool yourself by the 0 you had to add while you were doing math or whatever, your 10 there. And this one's significant to this point. So my answer has to be significant to which place? Where the 9 is or where the 5 is? Where the 9 is, right? Because the least, so what am I going to say? For decimal places, we're taking the one that is the largest, essentially. So this would be the tens, hundreds, thousands, 10,000s, 100,000s, right? 100,000s as opposed to the millions. Does that make sense? So farthest to the left, essentially, when you're looking at the number. And so what we're going to need to do down here, go ahead and take 30 seconds, round that. It's a little tricky, right? You're going to be rounding to hit this significant figure here. It's a 5, so we're going to round up, right? Yeah.
So we're subtracting.
Where what?
We're subtracting the 0.002.
Did I make a mistake here in my math?
No, I'm just asking.
I'm subtracting this from this.
Okay. So the one in the pattern has only 2 significant figures, and the one in the top has 3.
No. They both have 2 significant figures. This 0 there I added while I was doing math. Because if you want me to do math without long subtraction even, that's not a real 0 in terms of, it wasn't written there. I wrote it there so I could do my subtraction, if that makes sense.
But the 5 was there.
What was that?
Nothing.
Because the 5 was there under it. I needed to put a number there to work it. Sorry, it was a little confusing. Okay. If you're doing it on your calculator, you wouldn't have to worry about that so much, right? Okay, so if I round this up, right, this one is going to be, the 9 is going to round up to 10, right? It's going to make the next one a 2. So my answer is going to be 0.00020, lost a 0, 020 milliliters, right? I rounded this up, it became a 10. I had to jump the 1 over to here, but that number is still there. This is how many significant figures I have. And note it's lining up here, right? So it has 2 significant figures. Both of these had 2 significant figures, but where they went out to is important. Questions? Okay. Let's move on to multiplication and subtraction. And I realize we're moving fast today. It's just kind of the speed we have to move at to get through the stuff we have to get through for this class. If this is too fast, once again, you can watch the videos, you can come ask questions. This stuff's also in your book. Okay. And if you're not getting help, if you always remember, you've also got the tutoring center. We've got excellent tutors over there if you'd like help over there as well. Okay, so multiplying and dividing significant figures. All right, so here, this one's easier to describe at least. What happens when you're multiplying and dividing significant figures is your answer should have the same number of significant figures as the thing that the input that had the lowest number of significant figures. Okay?
It's been like that the whole time, right?
It has not. Here it's the place. So here both of these had 2 significant figures. Let me do it. I'm going to do another. That is a fantastic observation. Let's do another one up here, okay? I want to make sure that I clear that up. So let's add, let's say I've got 0.1432 meters, and I'm going to add 0.002 0.00014 meters to that. Okay. So I've got, this one has the smallest number of significant figures, right? But this one only goes out to the 2. It only goes out to the tenths, hundredths, thousandths, 10,000ths place, as opposed to going out to the 100,000ths place. Okay, so then if I add these two things together, I'm lucky. In this case, I don't actually need to put anything in there because I'm adding, right? I don't have to put anything up there. So I'm just going to put a 4 down here. Let's make it a little clearer. A 3, a 4, and a 1, right? Meters. Okay, but this one this was significant once that was the 10,000th place. This is significant to the 100,000th place, right? But, so we take the one that is farthest to the left, which is this one. And so our answer, we would round, chopping off that last one there, meters. Okay? So there's an example. Thank you for pointing out that out to me. That this is correct sig figs. That we didn't, in this case, have the same number of significant figures as the one with the smallest number, right? For adding and subtracting. For multiplying and dividing, the answer should have the same number of significant figures as the lowest, as the input with the lowest number of sig figs. All right, so what do we want for that? Let's say that we're going to do some density calculations today. So density is equal to mass over volume. There are various ways you could have various measures of density. We'll do grams per liter, okay, or grams per milliliter actually. Let's do grams per milliliter. So let's say I have, here, I'll write out a word problem. I have, oh, I gotta go in, okay. Actually, I'm not gonna do it like that. I have 2.50 pounds of sugar that I dissolve in 1.0 gallons of water. What is the density? Sorry about that. Move this way a little bit too. What is the density in, I'm going to make this pounds per liter. By the way, I told you guys I'm a home brewer. That's, if I'm making a mojito wine, that's how much sugar goes into it. Or not pounds per liter, pounds per gallon. Okay. And these are actually probably about how well I know these. I use my kitchen scale to measure out the pounds of sugar, and I've got some good units on that. And I try to fill the line on the gallon container, right? So it's not maybe 2 or maybe 0 gallons, but I'm not sure about that other digit. So I'm going to take 2.50 pounds and I'm going to divide it by 1.0 gallons. And I didn't bring my calculator, so let's use Google. Actually, is that yours?
No, it's not.
I'll take that then. Yeah. Somebody save me if it turns on. All right, great. All right, 2.50 divided by 1.0. Actually, what am I doing? I'm sorry. That's that losing 20 IQ points at the board thing. That's embarrassing. All right, so that gives me 2.50, let's say, right? My calculator actually did sig figs for me there, or chopped it off, but pounds per gallon. Okay? How many significant figures does this have? 3 sig figs. How many does this have? 2 sig figs. So my calculator in this case, and it won't always be like this, right? But my calculator in this case was correct. Calculators like to spit out all the digits, okay? They don't round for you. 2.5 pounds per gallon, and that's correct sig figs. Okay, questions? All right, so that's dividing, multiplying is the same. That one's pretty easy. What if we mix calculations? Okay, mixing calculations. So mixing addition, subtraction. And multiplication and division. All right, let's say we have the same sort of calculation, but let's say I'm making a 5-gallon brew, okay? If I'm making a 5-gallon brew, I can't weigh out, so I would need, if I'm doing 2.5 pounds of sugar, how much sugar would I need? 12.5, right? I need 12.5 pounds of sugar for a 5-gallon brew. So for a 5-gallon brew, and we're going to do, once again, 5.0 gallon brew. Actually, let's say I've got some magic 5-gallon container or some really expensive one maybe that gives me a bunch of significant figures. So I've got like a line. You could make something like this. And you'll see glassware in a lab that does it. This doesn't really exist for home brewers. You would never need this accuracy. But let's say for a 5.0 gallon brew, so that's my container, I add the following amounts of sugar. Okay. What is the final density in pounds per gallon? And so let's say I can really only do about 1.5 pounds on my scale, but I'm going to make it bigger so it's not super tedious here. Let's say I put in, so what, it was about 12, right? So let's say I put in about 4.134 pounds of sugar, and then I put in about 4.00 pounds of sugar. And then I decide, so I'm getting lazier as I go here in terms of making my measurements exact. I decide that I'm brewing, and it really doesn't matter that much if I'm off a little bit. And so for the last one, I put in 4.2 pounds of sugar because I'm really sick of weighing this stuff out. All right, so my measurements are getting less exact each time, and that's just related to me not caring as much. Okay, probably didn't switch my measuring device. So let's go ahead and add these up, right? So I'm going to go with a 4, and then I'm going to have a 3. Didn't line these up as well as I could have. And then I'm going to have a 3, and then I'm going to have a 12, right? So that's how many pounds of sugar I put in. When I think about this, what limits this in terms of number of sig figs? 1. This one, right? This has a sig fig one place past the to the right of the decimal place, so it's going to be limited there. All right. However, I don't at this point want to round because I'm going to be changing my results. I'm going to carry all my numbers through till the end if I can easily, and then I will fix it at the end. All right. So now I need to take to do density, I need to take my 12.334. We can remember it's that one. Pounds of sugar, and I can divide by my 5.000 gallons. If you guys meet Dr. Keith Lee, I don't know if he's teaching any Gen Chem. He probably isn't. He's our analytical chemist, and he'd love to have this, be able to measure that out to that accuracy. And he may have something that'll do it. All right, so I've got 12.334, and I'm dividing it by 5.000. And what that does for me is I get 2.4668. Added some more numbers even. All right, I'm going to just fix those in a second. So that's pounds per gallon. Okay, that's how many sig figs. So, but how many sig figs should that have? We're doing a division problem here, right? How many sig figs did this have?
1.
Not 1. It's 1 past the decimal place, right? That's right. But how many total? 1, 2, 3, and then we don't count those, so we carry the numbers along until we're done. So 3, how many does this have? 4. So this should have 3. So we're going to round it, so it should go to here, and we're going to need to round, and so my answer would be 2.47 pounds per gallon. Questions on what I did there? Okay. There, yes.
It's better just to round at the end instead of doing it before.
If you round it every step, sometimes you're going to you may distort the final answer. So you might end up, there's ways to reduce yourself to one significant figure at the beginning and then just blow out everything else, if that makes sense. Okay, so this is a better way of doing it. If this is really confusing to you, you can probably round at each step, and it'll probably be okay most of the time. That makes sense? But you might lose credit sometimes. I can't predict exactly. Yes?
I think you said this, but for that 5,000,
Yes.
those 3 zeros, what
Yes.
makes those zeros significant?
The zeros are significant. That's a great question. Why are these 3 zeros significant? These 3 zeros are significant because they are to the right of a decimal point, and these slashes are points, I apologize. But to the right of a decimal point, and it's to the right of a digit. Does that make sense?
Right.
So the way to the right of a digit is significant there is this. So let's say I had this number instead. These zeros are to the right of the decimal point, but they're not also to the right of a digit. So this would be one significant figure up here, not 4. Does that make sense? So that's one of our rules. Another way to think about them, and I don't know if this will work for you, when I think about it I didn't need to write those zeros. 5 gallons and 5.000 gallons are the same thing. So the fact that I wrote those, they're not placeholders or anything. fact that I wrote those means they're significant. If that works better, use that. Okay, whoops. Any other questions? Oh. All right, I just went over how to calculate density, sort of, right, as it turned an example. Did that make sense? Does anybody need to see another example of that? You can just nod. Okay, I am not seeing anybody. So another thing that's in your book is temperature conversion. So I want to cover that really quick. And this will be our first example of where we might use some algebra. So converting between Celsius and Fahrenheit. For time, I'm not going to struggle through spelling them, okay? So when we think about it, our equation for that is going to be that our temperature in Fahrenheit is equal to, and Fahrenheit's the temperature that we all talk about usually, right? How hot is it today? Somebody tell me. What was that? Yeah, it was like 55 degrees outside. That's 55 degrees Fahrenheit. That's how I expect everybody in the room. I don't know if I have anybody international, right? You might have to talk in Celsius. But in science, you'd use Celsius. So when I think about stuff I'm doing in science, I'm always thinking in Celsius, if not Kelvin. We'll talk about Kelvin later. But when I think about daily life, when I cook with my stove, it's in Fahrenheit. Okay? When I go outside, it's in Fahrenheit. But when I'm doing science, I think about Celsius. So we're going to have to think about these things together. So what that is the equation for converting from one of these to the other is this. Okay, so Fahrenheit is equal to 9 times the temperature in Celsius divided by 5 plus 32. In that order, we do all of this and then we add the 32. Let's use that and then let's figure out how we would do the reverse operation. So let's do this. So when I'm brewing, okay, this is also when you're cooking. 70 degrees Celsius will kill any bacteria, really, right? So if you're cooking and the inside of your food, if you have to worry, let's say you're cooking a burger, right? What's the problem? When people get like food poisoning for meat, it's often burgers. Why is that? Anybody have an idea? As opposed to a steak. People hardly ever get food poisoning from steak. There's more surface area, and there's actually more surface area because if they're at the slaughterhouse, right? Slaughterhouse is like this dirty whatever place where the things are not. It's not a sterile room or anything like that. Okay, don't imagine that. So you're getting all sorts of fun stuff on the outside of the meat they cut. So I have a steak, right? It's got bacteria all over on the outside. I'm vegetarian, but I wasn't always. When I cook that, why don't I get sick? Because I'm cooking the outside of that, right? How do you make a burger from a steak? Because that's what it's made from, right? You grind it, and so you grind the outside into the inside. Okay, so I can eat a really rare steak as long as it's seared on the outside, and I'm not going to get sick from that. But the burger has to be cooked all the way through because you grind the outside into the inside, and now the bacteria in the inside. So you have to get that to 70 degrees as well. Okay, I won't test you on this. It's fun fact. I've taught chemistry of cooking as well. And I love to cook. But, so, you kill all bacteria at 70 degrees. That's how hot you want the inside of that burger to get. So 70 degrees, now I'm going to spell it because it's easier than doing the little dot thing. Celsius, maybe. "70 degrees Celsius will kill all bacteria or anything you need to worry about when cooking." What is this temperature in Fahrenheit? This is just going to be a nightmare for me trying to. Did I get it close enough for spell check to save me? Yes. There we go. What is this temperature in Fahrenheit? Okay, so we're gonna go ahead and I'm gonna give you 30 seconds to do it. I'm gonna go over here and see if I can turn off my screen. I'm gonna work it as well. There we go. And I'm sorry if I took your equation away from you and you hadn't written it down. Oh, this will be a good significant figures exercise too, because I should have done a better job of it. But so try to get the correct significant figures as well. Oh, this is so painful. Okay, I'm going to go ahead and reveal my screen here. All right, and so this is the equation, right? I multiplied this times 9 divided by 5 in my calculator, all one thing. My calculator gave me my answer, and then I added 32 to that, and I got 158 degrees. Okay, I'm going to do a sanity check for this. Is that higher or lower than the boiling point of water? 70 degrees Celsius. Anybody know? What's the boiling point of water in Celsius? It's 100, right? That's why we like Celsius. It's easy. This is lower. I guess you don't know water boils at 212 degrees Fahrenheit. So I know it's lower. It's still pretty hot. 70 degrees is pretty hot. That seems about right. I probably didn't make a mistake there. Okay? I'm always doing this when I look at stuff. Did I make a mistake? Okay? To make sure I did that. So this is the temperature that my calculator spit out, and then I messed up when I gave you the Celsius, right? I probably know that 70 degrees Celsius at least to 2 significant figures, all right? I'd say I know it to 2 significant figures. It's about 70. 60 might be okay. 80 definitely does it, but really I should have probably put a decimal point there or underlined the 70, right? If I put a decimal point there, I didn't need to write it. I guess is another thing that maybe doesn't exactly follow our rules. I didn't need to write that. Does that make sense? So that would go there. But by our rules, I should have underlined it. So you might see that decimal point sometimes. I will avoid using it on you. Okay. So I should have written it like that. And I would have 2 sig figs, and then this could have been 160. But because I only gave you 1 sig fig there, it's going to be 1 sig fig in the end. Yes?
So I actually suck at algebras.
Yeah.
Can you go over that 9-5?
Sure, let's do that. What we've got, let's see, where are we for time? I want to rearrange this equation, and I'll be happy with that. So what we're going to do is I took 9 times 70, and then I divided that by 5. I don't know if that looks any different. If you have for your calculator, I took 9 times 70, and so that would have been 630. So I took 9 times 70 equals 630, and then I divided 630 by 5. and that gave me 126. And then I took 126 plus 32, and that gave me 158. Does that make sense? Okay.
Yeah.
And then I applied sig figs. All right, let's do the harder problem though, okay? And we know the answer here, but let's go ahead and do it use the equation. Water boils at 212 degrees Fahrenheit. Nope, didn't get it again. What is this in Celsius? Okay, one question here, one thing though here in terms of sig figs. I've got a 9 over a 5. Why didn't I apply those as one sig fig? We're doing the same answer, but it's a fraction, and fractions are going to have infinite sig figs. Okay, fractions, 1/4, 1/2. Okay, in math, those are just infinite. Otherwise, you'd have to express decimal points. Okay, so, and maybe I'll add that to our rules up in the notes after class. What is this in Celsius? I'm going to do this one for you because we have 7 minutes left. I don't care what this clock says. That says 9:23. This says 9:23, and I bet your phones say 9:23. So, but I'm going to work this one for speed. So my equation is Fahrenheit is equal to 9/5 times Celsius plus 32, right? I want to solve for Celsius, so I need to get Celsius by itself. So I'm going to have to do some algebra here. All right? Your rule for algebra. Algebra has one rule. You can do anything to one side of the equation as long as you do it to the other side. Okay? Algebra probably has a lot more rules than that. But for us, our rule is going to be you can do anything to one side of the equation as long as you do it to the other side. Okay, so I'm trying to get Celsius by itself. What I'm going to do first here is I'm going to subtract that 32 from both sides. So I'm going to go minus 32, okay, and I'm going to do a minus 32 over here as well. What that's going to give me is Fahrenheit minus 32 is equal to 9/5 times Celsius, right? Okay, now I want to get rid of that 9/5. I want to have Celsius all by itself alone. If I multiply this by its inverse, so I'm going to flip it, right? If I multiply 9/5 times, I'm going to multiply both sides times 5/9. Okay? Here I've got to multiply the Fahrenheit times 5/9 and the 32 by 5/9. I'm just going to put a parentheses around it and do 5/9 like that. On this side, what's going to happen is that 5 is on the top and that's a 5 on the bottom, right? So if I have 5 and I divide by 5, I get 1. You guys with me for that? And if I have 9 and I divide by 9, I get 1. So now that cancels. All right, and so if I rewrite this, my equation now goes 5/9 times Fahrenheit minus 32 is equal to Celsius. Okay, this is fairly complicated for one of these things for this class. All right, so now I can do the problem. I know that my temperature in Fahrenheit is 212 degrees, right? I'm just going to go ahead and plug this in. 212 degrees minus 32. And that's going to be times 5/9. So for my calculator, you can do this on your calculator as well, even though I'm not going to give you some time to do it, but it would be good to practice this. If you get used to knowing what your calculator can do and how to use it, you can save having to write a whole mess of stuff down. Does that make sense? I could write this down where I went 212 minus 32 and write it down and then do it. And maybe I will after this. But my calculator, if I go 212 minus 32 and I hit the equals, now it gives me a number. It says, okay, I've got a number, it's a lot. All right? And now I can divide by, well, I can multiply by 5 and then divide by 9. But it doesn't matter what order. So I'm going to divide by 9 because I accidentally pressed divide first. And then I'm going to multiply by 5. And what I get out is 100. And that warms my heart because I know it's the right answer, right? Celsius, we know water boils at 100 degrees Celsius. Okay? So what I get is that's going to be 100. I still have 2 minutes left, and I'm going to use them. Okay? I hate to waste class time. But let me go ahead. So I got 100 degrees Celsius. So what I was doing in my calculator, I could do this slower, right? I could go 212 in my calculator minus 32. Can I do that in my head? Is that 180? Okay. So 212 minus 32 equals 180. And then I know I've got 5/9 times 180 equals Celsius. And I could take 5 times 180, okay, 900, thank you. So I could take 5 times 180 equals 900, okay? And then I could take 900 and divide by 9. I'm doing all these pieces, and that gives me 100 degrees Celsius. Questions on that? On the algebra, you're going to want to practice that sort of algebra. We'll have lots of it in this class. Yes? No, you. Okay.
Instead of like flipping the problem at the very beginning of the example, couldn't you just plug in 212 at the beginning?
So you're saying, could you over here?
Like if you scroll up.
Yeah.
Yeah.
So you're saying, can you just plug in 212 here and then pull this over and subtract from it and then multiply that times 5 and 9? You're doing the same thing. But in that case, you're doing instead of rearranging the equation, you're doing all the algebra. You see how it's the exact same thing? You're just doing it with numbers. So you could do it that way too. It's fine. Yes. What was that? What would be the sig figs for that? Good question. 212. So let's look at sig figs here because I wasn't even thinking about it and I didn't indicate. That's bad sig figs, right? I just wrote 100. I didn't use my sig figs. It's 9:30. If you want to get up while I talk about the sig figs, I will not be offended. Go ahead. So let's look at that and get the sig figs correct. Great question. So here we have the 32. It's part of an equation, so I'm just going to assume it's exact. Okay? Assume that's exact because the 32 is part of an equation. And then, so I've got 212, so that is 3 sig figs, right? I'm assuming this is exact, right? So I've got 3 sig figs. I'm going to assume 3 sig figs out the other side, okay? And so, because each piece of this equation, so I should underline it like that. Does that make sense?
I was gonna say 32 has 2 sig figs.
It does. I'm assuming it's exact, meaning it has infinite sig figs. Now, if I had you guys doing it, this is a kind of confusing case. So if I have an equation, I consider the equation to be a definition. And so I think that everything in the equation as exact, if that makes sense. Okay, unless I'm using a constant from someplace that I know has a certain number. So I'm assuming the 32 is exact. Does that make sense? So it's infinite sig figs. So 3 limits it. But let's say, as you said, it still would be 3 sig figs, because when I subtract 32 from 212, it's that part is this, right? It's determined, it's a subtraction, so it's the ones place, so this would be significant. Do you agree? Does it make sense? Okay. And so if that's significant, then down here it's still significant, and I have this is, fractions are exact, it's also part of an equation, I can assume it's exact. I've got this exact stuff times 3, so I should have 3 significant figures in the end. And so I should underline those numbers. Because did that make sense?
Yeah.
Okay. And I'll post these notes, and there'll be YouTube videos if you want them for looking at that. Is your question about this stuff?
Yeah.
Okay, go ahead. I'll keep recording that.
So for the fraction, if you divide it, like the one before, or whatever the fraction was,
Lauren,
not
nice
just
to meet you. Do you play football?
and that would be 2 sig figs, but would you just say it's exactly what you suggested?
I would still call it.
Outside linebacker.
Okay. And then for that, you wouldn't do,
And it's part of the equation as well.
yeah,
There are no equations we're going to use in this class that aren't that are in essence that sig figs or the exact. Does that make sense?
yeah, so it'd be better to not do like 9 divided by 5 then times 7, or do 9 times 7.
Well, you can put your 9 divided by 5 times, and then you need to remember that that 1.8 that you get out is exact.
Okay.
Good question. All right, I think that's everybody in my class. We will stop recording.